Okay, guys, welcome back. This is a day 20, I guess, and more of a problem discussion. Like, I'll just start from the beginning of the topic. I'll discuss all the kind of models from HE Verma, the problems that you can see on left. I'll just discuss a few models and we'll just. Today's session is all about HE Verma. Okay, so just keep that in mind. uh, Burglar problems in the beginning, these problems are basically like kinematics problems, rotational kinematics. So there is nothing fresh about these two problems that you're seeing on the screen. It's quite easy. And then comes a problem like you apply some force and there is torque. So because of that, there is angular acceleration, which is also quite an easy problem. And then comes this problem, fifth one. Again, the same old thing. Like you can solve these kind of problems, right? You have mg sine theta, tension and alpha and all. I think this is a motor. Is this a motor or what? Yeah, it's easy only. There's nothing special in this thing. Like he has done the same thing, mg sine theta minus t and all. Okay. And coming to sixth, we've done this kind of, we can even give the answer of this problem just by looking at it, right? Like what would be the answer, guys? Anybody can anybody say it out on mic? Yeah, of course you might have seen this thing, but let me write this: m minus mg by m plus I by r square. This must be the answer, I guess. Okay, that's my guess. Can we slide down a little and check if the answer is that or not? Yeah, that is the answer. I mean, it is written in a different form, but that is the answer. So yeah, we can directly give these answers. I've already talked about it, and this is a very simple question where two kids are also playing on a seesaw, and where should the other guy sit? Balancing the talks will get it. Eighth problem: a ladder resting against a wall. Guys, if you have any problem with any of these problems, raise your hands and speak. Okay. So ladder kind of a problem. We've done this kind of a problem also. Like all you need to do is make that ladder stand, right? Mg normal force 1, normal force 2, and there must be friction so that it is stable. We've done this kind of problem, so that's it. This is an interesting problem. We've never discussed this. This kind of a ladder, like there is a two-way ladder, right? We've seen this thing with all the construction workers. This kind of a ladder, and he is standing. I mean, a person is standing on the top of, sitting on the top of a construction ladder, and this ladder must have this link in between these two. Can somebody tell me what is the importance of this link? The link that they have in between them. What is the importance of that link? Anybody? Aditya.
So the counter the torque created by the friction.
No, I would simply say basically all the other forces, if only there is enough friction, if only there is enough friction, you don't need this. But we can't completely rely on friction, right? There could be a smooth surface. Whenever there is a smooth surface, this link that we are looking, that I'm talking about right now, this link basically provides a tension in these opposite directions, just in case there is no friction. In this problem, I think he mentioned there is no friction at all. Let's see. Negligible mass on a frictionless floor. You see that? It clearly
Yes, the
says
friction.
they are standing on a frictionless floor. So the friction is absent. So these two forces actually hold it together. Otherwise, if you don't hold it together, you
Get
make it
split
stand,
apart and
it'll simply get apart. Like it'll simply tear apart, right?
yes, sir.
Right. Now, one more important question. When you are walking, let us say a slippery surface, completely slippery surface, right? This,
Yes, sir.
our legs are exactly like this, but already said it is slippery, but we don't have any support in between our legs. How are we making it together?
So actually the muscles near our hips.
Exactly, yeah. The muscles near our hips are actually holding it together. Otherwise, you will slip. And we all know that when it's a slippery surface, you don't want to take big steps, right? You only want to take very, very small steps so that our muscles in the hips can only take so much of tension. The muscles in the hips can only take so much of tension, and we don't have anything supporting us. Now, if only you have ever caught in a slippery surface and you have to take big steps, what you need to do is, like when you're standing, what you need to do is tie around some rope or something around your legs, not too tight, that will make you fall in turn, but with some gap in between it. Tie around a rope in between your legs. Whenever you slip away, whenever your feet slip away, they might provide you some tension and give you some stability. So whenever you are on slippery surface, you get my
But
point.
sir, what about our upper body, sir?
Oh, you need to have that balance. Come on, I can't give you everything. In that case,
Our upper body should be so
uh,
rigid
you
also, no, sir?
you
We
should make
have to place a plank over our back then.
no, you should make an Iron Man suit and fly off from the suit. Okay,
Yes,
so
sir.
there's no other way to do it. Aniket is in the waiting room. Shall we just we leave him in the waiting room just for fun? No. Coming back. So, guys, mark up this page number. It is in 185. Try to solve this question once. This is a good question. It gives you some idea about what we need to do. Okay. So that is 185. Page number 185. And then question number 10 is again angular momentum related question. All you need to do is write the angular momentum. Question number 11, 12, all these questions, like we've known this thing. Whenever you have a projectile motion, I'm not sure if I've completely discussed this. Whenever you have a projectile motion, you take any random point, you write the velocity and write the perpendicular distance. You can write the angular momentum, m into v into this perpendicular distance, let us call it as d. So that is angular momentum. Or I told you one more method to do it. What is that? At this point, when the body has velocity v, you try to take the components of it. So if this is alpha, v cos alpha, v sin alpha, try to write the angular momentum of this, try to write the angular momentum of this separately, try to add them, you will get the same answer. Okay, so that is question number 12. 13 is basically easy. He's simply asking the moment of inertia, I mean, like kinetic energy and angular momentum. 14 is a kinematics question, rotating angular speed, 20, rest, torque, inertia. Find the work done in the first 2 seconds. We've already talked about it. Work done. Whenever you need to find work done, normally we do integral ftx. Here we need to find integral tau d theta. So that is a work done related case. I'm sure a lot of you people have missed the worked out questions, but they are important. Okay, they make a lot of sense. So this is again, what is he asking? Acha, he's asking the velocity this time. By the time the block reaches here and this block reaches here, it has some velocity, it has some velocity, and it has some angular velocity. He's probably asking the angular velocity or linear velocity. I hope you can do it. Like all you need to do is energy conservation before and after, and you'll get the answer. And what else do we have? What is this question? Acha. Are we talking about question number 16 and this is the diagram? Yeah. Question number 16. Wait a second. Question number 16 and this is the diagram. This is an interesting question, guys. I'm not sure if you have seen it or not. What he says in the question number 16 is uh, there's a table, let's say a bench, a table, or whatever you call it as. Okay, and there is a hole in between, and through which you have a rope tied to a body, and the rope is like this. Okay, so what he asks is it's already rotating with some angular velocity. It's already rotating with some angular velocity. I think he says is like what happens when you pull it? This gets closer and it has to go with higher angular velocity because the angular momentum is conserved. So please mark up this question also. Question number 16. This is also an important question. It gives you some insight into some better ideas. So question number 16 is also important. Page number is 187. Page number is 187. I suggest you to note down these question numbers and page numbers. Okay. Question number 17. Acha, there is nothing. Like simply a rod is left here. When it comes down here, find the angular velocity kind of a question. Like kids can do it. And question number 18 is easy, moment of inertia. 19 is also basic question. 20 is also basic question. They're all 18, 19, 20. They're all finding moment of inertia questions. 21 is a question that we should be talking about. Look at this. A rod hinged at this point at rest, and there is a particle coming and hitting it, and the particle comes to rest. The rod gains some linear velocity and angular velocity. Can anybody tell me what to do in this case? It is not sticking, it just came to rest. Can somebody tell me how to do this question? Yeah, Aditya.
So since we know that it's an elastic collision, by seeing the question, we can just say like we have to just exchange the velocities between them.
No, but the collision didn't happen along the center of masses, right? It didn't
So we will
hit
take.
the body at the center of mass. So it's not easy. It's not that easy. Anyone else? How do you solve this question, guys? Come on, boys. Anybody? Nope. Sai Vamshi.
Sir, we can consider both of them are equal and we
Oh,
can.
okay, yeah. Sharath and Ganesh already texted in the messages also. Guys, I didn't see you, Flo. If you have anything to say, raise your hands. Vamshi, say it.
Sir, we can consider as together,
Consider the math.
and we can solve it.
Like, yeah, you can take this whole thing as a single system and then do what? Guys, anyone else? These guys are saying we can write the angular momentum. Okay, good. Angular momentum about any random point. I'm going to take the angular momentum about this point only. Initially, mv into this particular distance. After the collision, this came to rest. So it all this has no angular momentum because we're talking about this point only, but it has I omega. So initially it will be mvd. After it will be I omega. Now we can write the angular momentums fine. And what else can we do it? Can we go for energy conservation? Did he say the collision is elastic or something? No, he didn't mention anything about the collision being elastic or something. You can write linear momentums also. Conservation of linear momentum. MV, conservation of linear momentum. Capital M into some V dash. Let's just call this V dash, okay? You can conserve the linear momentum, you can conserve the angular momentum, then you'll get the answer. Okay, so that is how you solve this question. Okay, then since you find it difficult, why don't you people try, I mean the solution is right there. Why don't you people try the question number 21 also? Okay, which is in the page number 188, which is in the page number 188. So try the question number 21 also, which looks interesting to me, to you people too maybe. And then comes the rolling questions. These questions are easy. 22, 23, they're easy rolling questions. Again, easy rolling question. All you need to do is like mg sine theta minus f equal to ma. Mg sine theta minus f equal to ma. Friction value from the friction value is finding the mu value. Easy question. And then this question is talking about 25th question I'm talking about. Okay. Two cylinders of radii are given, moment of inertia are given. Initially, cylinders rotate about axis. The cylinders are moved closer to touch the keeping the axis parallel. The cylinder first slips over each other at the contact, but slipping finally ceases due to the friction. Find the angular speeds of the cylinder after the slipping ceases. You get my point? One cylinder is rotating like this, the other cylinder is rotating like this. They were brought into contact. After a while, they go with omega naught and omega naught such that this point, sorry, omega naught omega, they might have some new angular velocities, because I'll tell you why. They'll finally come to some omega 1 dash, omega 2 dash. There won't be any slipping in between them. Aniket, what is it?
Sir, both the omegas will be same, right, sir?
No. there is no slipping in between these 2 points, which means the velocities of these 2 points will be same, which is r1 omega 1 dash, r2 omega 2 dash. These two are equal. You get my point, Aniket? Now
Yes, sir.
r1 omega 1 dash and r2 omega 2 dash will be equal. This is the final angular velocities. Initial angular velocities is omega 1 and omega 2. The only same thing in between them is friction. One it will act here, and one it will act here. It's like, I'll just give you simple ideas, okay? Let me randomly take some values. This is going with 200 rpm.
So that lonely screen thing is there.
I'm sorry. This is going with 200 rpm, and this is going with 300 rpm. No, not 300, 100 rpm. Let's just say. Okay. After a while, they came down to some 150, and this came up to 120, such that, oh no, this is not gonna work. This has to go up to 180. Let's just say 180. Such that 150 into R1 must be equals to 180 into R2, so that the points of contact, they have the same velocity, which means the friction has bring this down, and friction has brought it up, which means if I have to write it, the friction direction will be like, oh no, it has brought it down, right? So the friction will oppose the motion of the first body but support the motion of the second body. All you need to do is write all the equations. The friction is same, the value of friction is exactly the same thing. You write the friction, you write the torque because of friction, F into R1, F into R2. Once you write the torque, you write a torque equals to I alpha. You can find alpha 1, you can find alpha 2. Once you have alpha 1 and alpha 2, you can write equations like this. Let me show. You can write equations like omega final equals to omega initial plus alpha into t on both the sides. Omega final equals to omega initial plus alpha t. So why don't you people look at this question also? This is also an interesting one. Okay. See how many questions you might have missed out on the worked out problems itself. They're really important, guys. Since it is rotational mechanics, I'm pressuring it to this extent. Okay. Question number 26 is easy. We've discussed this kind of a question. It's like a disc rolling down. That's all. It's like a disc rolling down, unwounding itself with V and omega. That's a very easy question, except they brought it in 3D. Like there are two strings around this thing. Instead of taking two strings, you can simply take one string and solve this problem. There is no difference at all. It's the same thing. So that is 26. Talking about 27. 27 is also easy. Like we've done these kind of rolling questions now. We've done this kind of rolling questions now. What is happening? Okay. Like we know if you apply force like this, the friction will act forward. We know when the force is applied here, the friction acts backwards. Guys, how many of you have seen the question that I posted on Instagram? Forward front wheel drive cars, rear wheel drive cars, because a lot of people are answering it wrong. Yesterday's question was wrongly answered by a lot of people. Today's question is also wrongly answered. Vamshi and Sharat, what do you people think?
Sir, first one I kept as left, sir.
I will give the answers, and in fact, I'm making a video on that. But it's very silly that you people didn't know this. A lot of people are making it wrong. If it is a front wheel drive, friction will be like this. Back wheels, friction will be like this. If it's a rear wheel drive, it's a simple thing. Like I don't understand why you people find it really
Sir, I
difficult.
put left, sir, but I didn't put right. Like for the
But
second
like,
one.
did you check the? I'll tell you what's the situation right now today in what do you say? Today's question. It's like around 50% of people again going wrong. Again, they're so stupid. Okay, so yeah, but you must know, or even if you don't know, I'll make a video on that. Okay. And question number 28 again a good one. Like v naught, and it also has omega, but that omega is not equal to v. That omega is v by 2r. So the body is not in pure rolling. The body is not in pure rolling. The omega is not v by r. It is v by 2r. It's not entirely the value that we need. So it will be a forward slipping case. Initially, there will be forward slipping v naught and omega naught by 2. Like if only omega naught is the original. Let's not write that. Okay, let's write it like this. They started like this, and after a while they will come to v1 and omega 1, and the whole thing, the whole transition. He is asking the final velocity and all. Okay, we've done this kind of questions in 28. So the 28 is also easy. And then 29 is a typical question, guys. Like this is a this type of a question are supposed to be, I mean, I can discuss, but before you people even not trying it, there is no point for me to discuss. Okay, so what he says is there is a body and a particle comes and hits it, and what happens after that? This is an interesting question. Take a look at 29th also. If only you can solve it, I'm I'll be glad. I mean, like, I'm sure you'll be in a very good position to solve a lot of questions in this topic. We've already discussed short answers, I guess. In objectives, somebody gave me some question numbers. Can somebody can you repeat the numbers, please? Whoever that was. Whoever that was, can you repeat the question numbers in objective one?
Sir, could you please explain that car one?
Which one?
The wheels one, sir.
I will make a video.
Okay, sir.
Because look at the rate of people who are being stupid on Instagram. There are around 3,000 votes on that. There are around 3,000 votes on that question, and half of the people were wrong.
Sir, I had two doubts also.
Yeah, what doubt?
Sir, while studying this chapter and center of mass and all, I got this confusion. When should we use vector product and when should we use scalar product, sir?
It depends on the quantity that you're trying to find. If you're trying to find a quantity like work done, you simply go for a scalar product. If you're trying to find a quantity which is like torque, you're going to ask for vector product. It depends on the quantities. Like, I can't give you a simple rule on that.
Okay, sir.
Okay.
Sir, and one more thing.
Yeah.
Suppose we have 4 rods making a square, and they tell us to find the moment of inertia of the rods along the perpendicular one to the square. So, like, how should we do it? Ml square by 12 for one rod plus md square, or the moment of inertia of that rod over there, say x plus md square is equal to ml square by 12. Which direction should we take, sir?
ml square by 12 plus md square, and you multiply it to 4 times. And that question we've discussed 3 times by now.
No, sir, that only, but
It was
we
in
have
the
to take from
DPP.
center of
It
mass,
was
right, sir?
2 times. It was in the exam 2 times, and it was also in the DPP.
Yes, sir, that's why I got doubt. From center of mass, we should take, right, sir? We are taking opposite.
No. The thing is, like, you're only doing it for one rod separately. Like, we are imagining that this is the only rod which is there at this moment. So you're writing ml square by 12 plus md square. Okay. Once you take for one rod, like once you find it for one rod, now we are imagining there are 3 more rods. That's how. Okay.
Sir, can we take it like, say it is x for one rod over there, x plus md square is equal to ml square by 12, like that we can take, sir.
You're not shifting anywhere, right? You only want it from the center of mass only. Like, so if only the value is x, that's it. That's the end of the problem. The value is the answer is x. He's asking about the center of mass itself, right?
Yes, sir.
So Ganesh is asking, Niti and Preeti are also asking us questions. Okay, Niti is asking 5th question. Let's look at the question number 5. Ganesh asked 10, 16, 21, 22. Okay. 5th question. Figure shows a small wheel fixed coaxially on a bigger one. The radius, the system rotates, the strings supporting A and B do not slip, X and Y are the distances. Now, guys, look at this. Obviously, if it rotates, this comes down by a distance x. This has to come down by x distance 2x, because the radius was given as r and 2r. So if it comes down by x distance, obviously the other part will come down by distance 2x, right? Because you see the length, you see the amount of rope that is coming out. It is exactly double because the radius is double. So you can directly answer that one. And I hope it's clear for Neeti and Preeti. Let's talk about question number 10. A uniform rod is kept vertically on a horizontal smooth surface. Okay, if it is rotated slightly and released, if it falls down on the horizontal surface, wait a second. A uniform rod is kept vertically on a horizontal smooth surface. Okay, if it's rotated slightly and released, it falls down on the horizontal surface. The lower end. Okay, guys, look at this. We've never came across this question. If only a rod is on a smooth surface, if only a rod is on a smooth surface and it is released, let's say it's slightly tilted, the rod falls like this at an instant like this, and then like this, and then like this, and then like this, as if the center of mass of the rod falls vertically downwards. Center of mass of the rod only falls vertically downwards. So the end actually goes by a distance L by 2. Okay, so please remember that point. Whenever you have a rod and the rod falls, it actually falls exactly like this on a frictionless surface. No friction. There shouldn't be any friction. The rod is initially like this. It will end up like this, where the center of mass just comes down clearly. Okay, that is question number 10. Ganesh, question number 16. A, a body having center of mass, bodies having its center of mass at origin has three particles. The moments of inertia of the body about x-axis and y-axis are given. The moment of inertia about z-axis. Now, first of all, like clearly watch what is happening here, Ganesh. X, z, and this is y-axis. Okay, this is y-axis. Now he's saying all the masses. Now all the points are not in a single plane. Not, you can't say all the masses are not in just xy plane. There is a mass on the z-axis also. So you can consider this as a 3D body. You can consider this as a 3D body. You cannot use perpendicular axis theorem. You cannot use the perpendicular axis theorem. Okay, Ganesh. So that is question number 16. Sharath, which part do you want? Sharath, please raise your hand and ask.
Sir, the previous question, sir, I didn't understand why will it stop at the horizontal position and then fall down, sir?
No, it won't stop at any horizontal position. It will start and it will come like this, and then like this, and then like this, and then like this, and it will fall eventually like this. The center of mass
Sir,
will
if
simply
the
fall straight. That's what I meant.
sir, while giving the force, sir, if there's some sort of a elastic collision, sir, then the rod will keep rotating, right?
Like if where are you giving it a collision?
Sir, like while giving force, sir.
No, that force is like very minimal, like f tending to zero, very small, so that it disturbs, and that's all.
Okay, sir.
Okay, if only
Sir,
you
so like
put some
what?
force, of course, then it will definitely move. Okay.
It'll keep rotating because there's
Yeah, it
no
will keep
friction, right?
rotating and all. Okay, that's a different case.
Okay, sir. Thank you, sir.
Okay, after question 16, he's asking question number 21. Question number 21. Okay, a wheel of radius 20 centimeters is pushed to move it on a rough horizontal surface. It is found to move through a distance of 60 centimeters on the road during the time it completes one revolution about the center. Assume that the linear and angular accelerations. Wait a second. The wheel of radius 20 centimeters is pushed to move on a rough horizontal surface. It is found that found to move through a distance 16 on the road during its complete one revolution about the center. Okay. Assume the linear and angular accelerations are uniform. The frictional force acting on the wheel by the surface. Uh, This sounds a bit difficult. I mean, like, Acha, he's trying to find, he's asking us to find whether it's a forward slipping case or a backward slipping case. Okay. The radius is given as 20 centimeters, which means in one full revolution, it's like this. In one full revolution, by the time it gets here, by the time it completes one full revolution, it has to travel by a distance 2 pi r, which means 2 pi into 20 centimeters, which is around, this is around 6 point something, so you'll get 120 centimeters or something. But he clearly said it only moved 60 centimeters only, which means the linear velocity is not sufficient. The body is not linearly moving sufficiently. So V is very small and omega is very large, which means in this case R omega and V, it's a backward slipping case, so the friction acts forward. Ganesh, I hope I made it clear. 21. That's a good question. He's just simply asking us whether it's a forward slipping case or a backward slipping case. Okay. After 20, wait a second. 21, 22, you asked. 22. Let me go back to 22. An angular velocity of the engine of a scoot is proportional to the petrol put in. The scoot is moving on a frictionless road. If it is on a frictionless road, there is no point how fast it rotates. It can rotate with 1000 rpm, it can rotate with 10,000 rpm, it won't go forward. So the speed at which it goes will not change. So the linear velocity of the scooter doesn't increase at all. So I hope I cleared it also, Ganesh. So 22. Someone else asked 24 and 25. Santosh Chakradhar, 24 and 25. Solid hollow sphere all having mass frictionless surface, least time taken. We've already discussed this. I even show you the animation, like when we release all the kinds of bodies from the top of our inclined surface, which reaches first and which reaches the last. I think ring reached the last. So ring takes the maximum amount of time. That is that. After 24, 25, again the same question: who has the highest amount of kinetic energy and highest potential? We've discussed all these things, so I'm not discussing them again. Okay. Any doubts in objective 2, guys? Any doubts in objective 2? Ganesh is asking objective 2, second question. This is a long topic, Ganesh. L equals to I omega and dl by dt equals to tau. In non-inertial frames, it's a long topic. I have to give you a lot of examples. Okay. Aniket, what is it?
Sir, objective 2, can you discuss whole once?
Why?
So it is quite tough, sir, that's why.
Then I won't discuss at all.
Sir?
Then I won't discuss at all because you people are being lazy and not trying it at all. You must be, like what do you say? How do you put it? You don't even deserve to know the answers of these questions if you don't even try. Like all the questions are difficult means you're not even, good enough to go through the questions. You at least get some questions and ask me some other more doubts, then we'll talk. You're simply asking me to just narrate this as if I narrate a movie story. No, I cannot do that. Ganesh, I'll do it in person. We'll separately discuss. Like you express your thoughts on the second question, and I'll express my thoughts. Okay. This all the second level questions, objective 2 questions are really good. But if you ask me some doubts, I will discuss. If you ask me everything, then no, I won't. Aniket, what is
Sir,
it?
fifth one also.
What?
Fifth one, sir.
You just said you asked me to all discuss all, right?
Yes, sir, but I solved few.
Then
And
why
second
did
one, can you discuss with me also, sir, in person?
No. Are you
Second one, sir.
Are you a deserving person?
Yes, sir.
How?
I tried, sir.
No, that doesn't make you a deserving person. Okay, you're not eligible for now. Let me decide it later. I'm discussing fifth question. Let IA and IV the moment of inertia of a body about two axes A and B respectively. The axis A passes through the center of mass and B does not. It's very clear, like I center of mass is the least, no matter what. Or you can, but sometimes you need to be careful. If the other axis is perpendicular to it, let us say like this is mr square by 4 and this is mr square by 4. This is mr square by 2. In this case, I center of mass is not less. It's only reasonable that you can say I center of mass is least when you're comparing with other axes which are parallel to it. About all these axes, the moment of inertia is more than this because you're always writing plus md square, if they're parallel. But if only you're talking about perpendicular axis, there is a chance that it might happen. Okay, so he clearly asked that IB is greater than if the axes are parallel. Yes, answer C is a good answer. Okay. If the axes are not parallel, we can never know. We can't say it. So Vamshi is asking eighth. It has went to a different dimension. Wait. Where did we go? Yep. She's asking eighth question. Let's look at this question. Consider a wheel of a bicycle rolling on a level road, okay, with a speed. The speed of a particle. Vamshi, raise your hand. What's your doubt in this? We can talk about the speeds of all the particles. What's your doubt? Vamshi, what is it?
Sir, not in this, sir.
Ah,
In which next, sir, exercises.
in exercises, you want the eighth one.
Yes, sir. I'm not understanding that question.
He says there is a disc which is wrapped up and there is a body attached to it. He's given the omega. He's asking V. We can't find that.
Yes, I can find, sir. No.
I'm not discussing exercises. We've done with the exercises. Okay, I'm done discussing exercises a long time ago. We've discussed all these questions bits by bit. So I'm not discussing exercises. I think we are done with objectives. If you people haven't tried objectives, you try them again. You let me know. And today you are going to solve the DPP, the assignment that I gave you, and you come back with the doubts from the DPP. Tomorrow discussion will be about DPPs only. The complete discussion will be DPPs. Aniket, what is it?
Sir, what about material discussion, sir?
If you have time, yeah, we can do that also. If we have time.
When, sir?
If we have time, like I said, maybe tomorrow or day after tomorrow, depends on the time. If we don't have time, how can I adjust everything?
Okay, sir. So because DPP we did discussions already. Material till now we didn't do even one.
I know. DPP level 2 we haven't discussed. Didn't
Yes, sir.
discuss the rolling motion and all. So that part. DC Pandey only Raghav is doing. If anyone else is doing, please discuss along with Raghav. You two join and discuss and then come to me with the doubts. Okay, Raghav, you don't just come to me with doubts. Why don't you discuss with someone else who's parallelly doing with their DC Pandey and then come to me with the doubts. Okay. So that's it, guys. That's it for today. I think the time is up. It's already 4:20. We can meet again tomorrow with some more doubts. So thanks so much and bye bye.